In this pre-algebra video, Chapter 2, Lesson 2, we're going to talk about solving two-step equations. Our objective is, as the student, I can solve two-step equations because I will apply inverse operations and the order of operations in reverse. Just a reminder, inverse operations are operations that are opposites of each other. They're operations that undo each other. So for example, adding and subtracting, they undo each other. They're opposites, or multiplying and dividing, those undo each other. Or square rooting and squaring, those undo each other, meaning they're inverse operations. We're going to use these inverse operations. That's going to be how we're going to move stuff, but we're also going to have to talk about the order. Let's do some examples. So for example, let's say we're wanting to solve this two-step equation. And when you're solving an equation, what that means is you're isolating the variable, you're getting it by itself. Meaning, on the left side of this equal sign, we want to see nothing but the z, which means we need to get rid of the minus 17, and we need to get rid of the times 5. So what we need to do is get rid of 5 and minus 17. That's the what. Now the how is what we just talked about on the other slide. How you move things is going to be by doing the inverse operations, meaning how do you undo them? So we're going to move them to the other side of the equal sign, the 5 and the minus 17. Okay, so now we talked about the how, the what, now the when, meaning what order do you move these in, because the order you move them in does matter. It will change your answer. The order that you're going to move these in is going to be the order of operations in reverse. Notice we have multiplying and we have subtraction. The one that comes later in the order of operations is subtraction. Subtraction comes after multiplying. Because it comes later, we're working backwards. So that means when we're undoing things, that's the first thing that we're going to undo. So we're going to start by adding 17. And the rule with the equations, if you remember from last year in 7th grade, we said whatever you do to an equation, okay, you can do whatever you want, but you must do it to both sides of the equal sign. That way it's still equal. If you only did it to one side of the equal sign, it would no longer be equal on both sides. Alright, well, they cancel on the left side. Notice there's 5z. Now on the right side, you have 13 plus 17. Well, 13 plus 17, that's going to be 30. So you have 5 times z equals 30. Now, to finish from here, you have to get rid of times 5. You know it's multiplication because they're touching. So the opposite of multiplying is dividing. So you're going to divide both sides by 5. They cancel on the left side, and you're left with z equals 6. So that means the value of 6 is what will make this equation true. And if you're not sure, plug it back in. 5 times 6 is 30. 30 minus 17 is 13. So we would have 13 equals 13. Well, hey, that's a true statement. Therefore, that's definitely our solution. That's how we check our answers. This is one of those topics in math where you shouldn't be guessing whether or not you have the correct answer or not, because you can quickly check. Now in this example we have to the bottom right, we're going to still get a by itself, but you'll notice it looks like we only have one thing to move. But I want to point out, when we move it, by the way, it's negative 24, and the opposite of negative 24 is positive 24. So we're going to add 24 to both sides. That was a side thought, but my main point was I want to emphasize is, now that the 24 is gone, on the left side, you still have a, but that minus sign in front of the a doesn't go away. So you actually have negative a in front of that minus in front of it. So that minus sign becomes a negative sign for a. So then on the right side, negative 15 plus 24, well, that's going to be positive 9. And to make sure that we're clear, guys, of why we added 24, anytime you move an entire term, for example, negative 24 is a term, a is a term, 5z is a term, 17 is a term. Anytime you move an entire term to the other side, you know they're terms because they're separated by addition and subtraction. So anytime you move an entire term, I promise you it'll always be by either adding or subtracting. You make your decision by looking to see what's in front of it. So in front of this 24, we had a negative sign. So in order to get rid of it, we had to do the opposite, which was adding. If we wanted to, let's say we wanted to move this minus, we want to move a to the other side. If we were going to do that, we would look at it and see that it's minus a or negative a, and the opposite of that would have been positive or plus. We would have added a to both sides if you wanted to move it. So I want to make sure we're clear on how to move the entire terms. Anyways, now we're left with negative a equals 9. Well, if negative a equals 9, we want to know what positive a equals. And a lot of people intuitively can be like, well, if the opposite of a is positive 9, that means a must be negative 9. And that is true. A is negative 9. But to help you understand why, if it helps make more sense, pretend there's a 1 in front. Pretend that the coefficient is negative 1. Now pretend you're just doing what you would normally do to move a coefficient. To get rid of a coefficient of negative 1, you would divide both sides by negative 1. They'd cancel on the left, and you'd be left with A. And on the right side, 9 divided by -1, well, that's -9. So that's a way to kind of explain, another way of explaining why the signs are changing. So that means A equals -9. That's the value of this equation that would make it true. That is the value for the variable that would make this equation true. Alright, so I've now got two examples for you to try. I want you to work on solving both of these using the order of operations in reverse. And essentially just remember to start with what's kind of furthest away from your variable and move that first. Alright, hit pause and try these. Press pause. Alright, so for our first one on the left, we need to start by moving -8 because it's furthest away, but also because subtraction comes later than division in the order of operations. So because it comes later, it's the first thing we're going to move. So to get rid of -8, you do the opposite. You add 8 to both sides. And by the way, I want to point out, when you're doing something to both sides of the equal sign, as a quick aside, this is almost like vocabulary, but I'm not going to make you write these down. They're really easy. Is the property that we're using right now by literally adding 8 to both sides, that property is called the addition property of equality. And that just means you can add whatever you want as long as you do the same thing to both sides of the equal sign. So if you do the same thing to both sides of the equal sign and you're adding, it's the addition property of equality. So for example, when we added 17 to both sides, that was the addition property of equality. Here, when we divided both sides by 5, that's called, think about it, the division property of equality because we divided both sides by the same thing. So I just want you to know there's one of those for all four of the main operations, the addition, subtraction, multiplying, and dividing. If you do it to both sides, it's called that operation, property of equality. Anyways, but that's more of a vocabulary, but I want to make sure you recognize and understand those. Alright, so the cancel on the left side, so we're left with k divided by 5 equals -2 plus 8, well that's +6. So now you just have to get rid of divided by 5. To get rid of divided by 5, the opposite is multiplied by 5. So I'm going to multiply everything by 5 on both sides. The 5's cancel on the left side, and we're left with k. And on the right side, we have 30. So k equals 30. That is the value of this equation. That'll make it true. And remember, if you have any doubt, or even if you just don't want to be overconfident, plug 30 back in. 30 divided by 5, well that's 6. So we have 6 minus 8. 6 minus 8 is -2. So we have -2 equals -2. Because now the left side is equal to the right side, so that's correct. So it's a true statement, which means 30 definitely was our solution. And by the way, I don't want you to use highlighter to check your answers on top of yours. I'm doing it for space reasons, just showing you literally plug it back in. But you can write it right below your problem to check your answer. Alright, so make sure you have that example correct. Now the one on the right, order of operations in reverse. If you haven't already done so, hit pause and try it. Okay, so the first thing we need to get rid of is the divided by 3. And a lot of you might be thinking, well, hey, wait a minute. Subtraction, that comes later in the order of operations than division does. So why all of a sudden are we moving the 3 first? And here's the reason. Imagine that you have parentheses up top. And in other words, you must do everything up here before you can divide by 3. Because notice, it's everything up here divided by 3. It's everything up there. So that means you must do everything that was up there before you would be allowed divided by 3. But since we're working backwards, the divided by 3 is the first thing we're going to move away. So because the top has an implied or an assumed grouping symbol around it, that's why the division actually comes later in the order of operations in this example. That's why I mentioned earlier about grouping symbols sometimes can make it seem confusing. So that means the first thing we're going to do in this problem is multiply both sides by 3. So we can get that 3, move it to the other side. So the 3's cancel on the left side. We're left with x minus 4 equals, and on the right side we have 15. So now your job is just to get rid of the -4, and to get rid of -4, do the opposite, which is add 4. Oh, and by the way, us multiplying both sides by 3, that's called the multiplication property of equality. Us multiplying both sides by 5, that's the multiplication property of equality. That's how you know you're allowed to do what you do. In other words, you're doing the same thing to both sides of the equal sign. Those should sound familiar. We did talk about them last year. So you're left with x equals 19. And that's your final answer to this question. And if you're not sure, plug it back in and see if it gives you a true statement. When you work your way through these questions, I want you to be neat and organized, and it's very important that you learn how to show your work and justify your steps. By justifying your steps, not only are you showing your work literally by writing your steps, but literally if you were asked to justify how do you know you're allowed to do that, in this example you would say, I'm allowed to do that because of the addition property of equality. This one because of the multiplication property of equality. So be able to show your steps and justify them. Alright, give this example a shot, and you'll notice, yeah, you're going to have to deal with that rational coefficient, but it just means you're going to use the skills we learned in the last section. Press pause. Alright, so the first thing we have to get rid of is that minus 4 because it's furthest away and also because it comes later in the order of operations. Cancels on the left side, and so on the left side we're left with negative 2/3 m, and on the right side 10 plus 4 is 14. So you're left with nothing but a coefficient to get rid of. And remember we talked about in the last video, when they're touching that means multiplying, so no matter what it is, you can move all coefficients by dividing. This is the same way we describe this skill in the 7th grade. The coefficient's negative 2/3, so you're dividing both sides by negative 2/3. So they cancel on the right side. So on the left side, you're left with just m equals. Now on the right side, it might be time for you to show your work. Use your fraction skills. So you're going to have 14 over 1, and now you're dividing by a fraction. Remember how to divide by a fraction. You multiply by the reciprocal. It's still negative, but we flip it, so it's 3 over 2. So now use your fraction skills to find out what this equals, and you'll have your answer. Some of you like to not use the fraction shortcut. Some of you do. The fraction shortcut works like this. You look at things that are diagonal and you see if you can simplify them. 1 and 3 do not simplify, but 14 and 2 do simplify. So this is like cross-canceling or cross-simplifying. It's called different things. But essentially, you see 2 and 14, they simplify by 2. 2 goes into 2 one time. 2 goes into 14 7 times. So now you can multiply the problem just like you would have, but now using those new numbers. So 7 times 3 is 21, and on the bottom 1 times 1 is 1. A positive times a negative is a negative. So we have negative 21 over 1, and that just equals negative 21. So the answer to our question is negative 21. Now, if you didn't like using that shortcut, you could have just multiplied straight across. Meaning you could have done 14 times 3, you would have gotten 42, and then on the bottom you could do 1 times 2, that would have been 2, so you would have had 42 over 2, you would have simplified top and bottom, you would have ended up with 21 over 1. So you still would have ended up with the same answer, you just had an extra step of simplifying. Make sure you have these proper steps shown. Okay, we'll make this your last example that you're going to do, and I want you to try this one, and I call it a challenge so it can have multiple steps. And yes, it does have a fraction inside of a fraction, because this is technically one big fraction. It does have a fraction inside of a fraction. It happens. It's possible. So go through and be careful, order of operations in reverse, and solve this one. But I'll give you a hint. Remember, the top is pretend it's inside of parentheses. So that means the first thing you're going to get rid of is the 8. Alright, since the 8's the first, so hit pause if you haven't done so already. So if 8 is the first thing you're getting rid of, you're getting rid of divided by 8. You do that by multiplying both sides by 8. That's an ugly 8 squeezed in there. Let's try that again. That's a little better. Squeeze in an 8. Alright, so multiply both sides by 8 in order to move that 8. So the 8's gone. So now on the left side, you're still left though with 3/4 x minus 4. 2 times 8 is 16. Now look what you have. You now have a two-step equation. It just took us a moment to get it there. So it's going to be just like all those other questions. Let's get rid of minus 4 first. And if you do that, they cancel on the left side. So on the left side, you have 3/4 x, and on the right side, 16 plus 4 is 20. So now you're down to a one-step equation. And in fact, it's a rational coefficient equation. I'm going to move it up here so I have room. Remember what we just talked about in one of the last slides? To get rid of any coefficients, you divide. So what if it's a fraction? We're going to divide both sides by 3/4. And when you do that, they're going to cancel on the left side, and you're going to be left with x equals, now on the right side, we just have to figure out what is 20 divided by 3/4. So that's 20 over 1 divided by 3/4, multiply by the reciprocal, so multiply by 4 over 3. Now we're ready to knock it out. We're going to, in this case, unfortunately, we don't get to use our shortcut. It doesn't exist. So we're just going to have to do this the regular way. So multiplying straight across. 20 times 4, well, that's 80. 1 times 3, that's 3. So we have 80 over 3. Well, that's an improper fraction. We're just going to simplify it and convert it to a mixed number, and we'll be all done. So take a moment to convert that to a mixed number. Alright, so 3 goes into 80 26 times, and it gives it a remainder of 2. So 26 and 2/3. That's going to be our final answer. X equals 26 2/3. That is the final answer to this question. Oh no, it's scary as a fraction. But the truth is, guys, don't get bogged down by the fraction. Focus on what we did. We simply did we undid the order of operations in reverse. We got rid of the 8, we got rid of the -4, and then we got rid of the coefficient 3/4. And we just did it in the proper order, and so we got our final answer. Alright guys, make sure you have all your steps shown. Make sure your notes are complete in quality and you try them on your own. Come to class prepared. We'll take it to the next level.